Differential equations, type 2, real world, A, linear motion. 2013, question 10b states that a particle starts from rest at 0 at a time equals t equals 0. It travels along a straight line with acceleration of 24t minus 16, where t is the time measured from the instant when the particle is at 0. Find 1, its velocity, and its distance from 0 when the time is equal to 3. Okay, so we're going to start with part 1. And our equation given to us is acceleration is equal to 24t minus 16, where t is our time and our acceleration is in meters per second squared. So if we're looking for velocity, we're going to use the fact that acceleration is the rate of change of velocity with respect to time. And we will then see, well, what limits are we given? So in other words, what do we know at the start and what do we know at the end? Well, at the start, we can see that the velocity and the time is 0 because it is starting from rest. So t is equal to 0 and v is equal to 0. Units are given, so we'll use them. And at the end, we're looking for its velocity when the time is equal to 3. So if we take this equation, and we're going to rearrange so that we get velocity on the left and our time on the right. And then we'll put in our limits. So we're integrating the left-hand side with respect to v and the right-hand side with respect to t, where our upper limit is v and our lower limit is 0, and our upper limit is 3 and our lower limit is 0. Okay, so if I go on to the next page for our integration, if we integrate with respect to v on the left-hand side, we end up with v. And if I integrate the right-hand side with respect to t, we're going to increase the power by 1 and divide by the new power. And therefore our limits are 3 and 0. Okay, so subbing in our limits then, that gives us v minus 0 on the left, and on the right, 24 divided by 2 is going to be 12t squared, where of course t for the upper limit is 3, minus 16 times 3, and then our lower limit is 0, so obviously if I sub in for 0 there, my t's are just going to give me 0. So therefore my velocity when the time is 3 seconds is 60 meters per second. So we were only getting 5 marks for that part of the question. So we then have to also find the distance. So we can see that when I integrate dv dt, I get an equation here for my velocity, which is v is equal to 24t squared over 2, in other words 12t squared, minus 16t. So if we're looking at that with respect to any limits, so in other words just our general, what we would have then is the fact that v is equal to 12t squared minus 16t. So now if we want to take that and we want to find our distance, well, what do we know about velocity? Well, we know that velocity is the rate of change of distance with respect to time. So now I can integrate to get my distance when the time is 3. So in other words, what do we know at the start? What do we know at the end? In other words, what's our upper limits and what's our lower limits? So at the start, the time is 0 and the distance is 0 because it hasn't moved. And at the end, the time is 3 seconds and the distance is what we're trying to find. So if I get all my s's on the left and my t's on the right, and I look at my limits, I'm integrating the left with respect to s and the right with respect to t. Then when I integrate the left, I get s within the limits of s and 0. On the right hand side, I'm going to get 12t cubed over 3, which is of course 4t cubed, minus 16t squared over 2, which is of course 8t squared. Upper limit being 3 and lower limit being 0. So if we sub in our limits, then that gives us s minus 0 on the left, so upper minus lower. And on the right hand side, I'm going to have 4 times 3 cubed minus 8 times 3 squared, minus the lower limit, which is of course 0 when I sub in for 0. And therefore I end up with s is equal to 36 meters. So we were getting 5 marks for getting our formula for s and 5 marks for solving. So 15 marks for part 1 altogether. Okay, so if we go back to the question, the next part says then, find the value of t when the speed of the particle is 80 meters per second. So in other words, we have worked out our velocity equation here. So if we know what v is, we can then work out what the time is. So this is part 2. So we say that v is equal to 12t squared. Sorry, v is equal to 12t squared minus 16t. But if v is equal to 80 meters per second, then that gives me 12t squared minus 16t is equal to 80. And I can divide across there by 4, which gives me 3t squared minus 4t minus 20 equals 0. So now I just have a quadratic to solve. So factors that multiply to give me minus 60 and add to give me minus 4 must be minus 10 and 6. Or solve however you want, your scissors formula or your minus b formula. Okay. So we have 3t squared plus 6t minus 10t minus 20 equals 0. So taking out the highest common factor, we end up with 3t times t plus 2 minus 10 times t plus 2 equals 0. So t plus 2 is our highest common factor, leaving us with 3t minus 10. And letting both of those factors equal 0, we get t equals minus 2, which we know obviously isn't possible because we can't have negative time. Or t is equal to 10 over 3, and that is seconds. So can't have negative time. Okay, just not possible. So we were getting 5 marks for working out our time. So only 20 marks going for that question that year. But a nice little question all the same.